this lesson, we're going to cover x and y intercepts, finding slope, writing equations of lines in point slope and also slope-intercept form. We're going to graph a linear function and then also look at parallel and perpendicular lines. Our first definition is an x-intercept. The x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. The y-coordinate corresponding to that x-intercept is always going to be a value of 0. And then for the y-intercept of the graph, it's the y-coordinate of where the graph intersects the y-axis. And the x-coordinate corresponding to that y-intercept will always be 0. So it's kind of nice because for the x-intercept, y equals 0. For the y-intercept, x equals 0. In this example, it says identify the x and y intercepts. So you can see the line right here. When you go from left to right, the line is going up, so this will have positive slope. The x-intercept is right here at -3, so we're going to label that -3, 0 for the x-intercept. The y-intercept is going to be where the graph crosses the y-axis, and that's right there at 5. So we list it as 0, 5. For part B, we have a horizontal line that hits at 4, and this graph does not cross the x-axis. So for x-intercepts, we're going to say none. The line crosses the y-axis at 4, so we say the y-intercept is 0, 4. For this line in part C, you can see the graph hits the x-axis at 0, 0, and also for the y-intercept, the graph hits at 0, 0. So the x-intercept and the y-intercept both are going to be the point 0, 0. This example says the temperature at 6 a.m. on Monday was 60 degrees Fahrenheit. The temperature rose steadily until it reached a maximum of 85 degrees at 3 p.m. The temperature then dropped steadily and again was 60 degrees Fahrenheit at 6 p.m. Which of these graphs represents this time-temperature relationship? The first part of the problem says that starting at 6 a.m., the temperature is 60 degrees Fahrenheit. So if you look along the y-axis, that represents the temperature. And then for all of these graphs, it looks like graph numbers 3 and 4 will be reasonable guesses to start because they're both just above half, right about 60 degrees at that 6 a.m. So next I'm going to check, it says the graph reaches a maximum of 85 degrees at 3 p.m. So looking along the x-axis, it says 6 a.m. to 6 p.m. So right in the middle would be 12 p.m. or noon. And you can see that again, it said that at 3 p.m. the temperature maxes out at 85 degrees. So between choices 3 and 4, it looks like this one's going to max out in the morning before noon versus this one has a maximum after noon, which falls right at about that 3 p.m. time. So let's just triple check the rest of it. It says the temperature then dropped steadily and again was 60 degrees at 6 p.m. So that makes it answer choice number 4. So I just put a little check mark next to that graph. Here we have equations of lines. Point slope form is y minus y1 equals slope times the quantity x minus x1. Slope-intercept form is going to be y equals mx plus b. A horizontal line is going to be y equals a value. A vertical line is going to be x equals a value. This example says find the slope of the line passing through each pair of points. So what we're going to do is we're going to consider this x1, y1, and then consider this x2, y2. I'm going to go ahead and label that. Go ahead and write up here the formula for slope. We have m equals y2 minus y1 over x2 minus x1. And we're going to use this formula to find slope. So we're going to start with y2, which is -2, and then we're going to subtract y1, which is 4. In the denominator, we're going to do x2 minus x1, and then be sure to use parentheses. So now that I have it set up, we're going to simplify on top and then simplify in the denominator. So -2 minus 4 is -6. And then in the denominator, a negative is going to be positive, so you get -4 plus 3 is going to be -1. So the slope ends up being 6. Let's do the same thing over here. Label x1, y1, x2, y2. And then go ahead and plug these values right into your formula for slope. So you start with y2, which is 5. So you plug in 5 minus, and then y1 is -2. Again, use parentheses around the y1. Same thing in the denominator. We're going to go x2 minus x1. So we'll go -1 minus 4. And now in the numerator, you get +7. And in the denominator, we get -5. And that gives us our answer for slope. It's -7/5. You can put the negative on the bottom, you can leave it out in front, or on top. Any one of them is fine. This example says write the point slope and slope-intercept form of of the equation of a line with slope 6. So I'm going to label that M, and the line passes through the point 2, negative 5. So we'll label 2x and negative 5 as y. Next, I'm going to set up an MXY chart. So we're going to plug in the M, the X, and the Y. And let's go ahead and plug these into the point slope form first. And point slope form is going to be y minus y1 equals M times the quantity x minus x1. So I wrote it right here for reference. We're going to take 6 and plug it in for M. We're going to take this 2 and plug it in for x right here. And we'll plug in y as negative 5, and we plug it into this y. I just multiplied these to get y plus 5 equals 6 times the quantity x minus 2. So that's going to be point slope form. Now we're going to rewrite this to get the equation in slope-intercept form. So I'm going to take the 6 and distribute to both. So when you do so, you get 6x, and then 6 times negative 2 is going to be negative 12. And the very last step, we're going to get rid of this 5, so we're going to subtract 5 from both sides. And when you do so, you end up getting y equals 6x minus 17. And that's going to be our slope-intercept form. All right, so there's our equation written in both forms. This example says, write the point slope and slope-intercept form of the equation of a line that passes through the points negative 2, negative 1, and also negative 1, negative 6. So this time, we need to find slope. So I'm going to label the 2 points. So this first one's going to be x1, y1, and the second point is our x2, y2. So we're going to use the formula for slope. When you're doing the formula for slope, make sure you start with y2, and then we subtract y1. In the denominator, we're going to start with x2 and then subtract x1. So x2 is negative 1, and then we subtract x1. Make sure to use parentheses. Okay, so in the numerator, we have a negative negative, which turns positive, so we have negative 6 plus 1 is going to be negative 5. In the denominator, the same thing, negative negative is a positive, so we have negative 1 plus 2. And that becomes positive 1. So now we get negative 5 for slope. Now that we have slope, we can use either of these points to write the equation of a line. I'm going to start with just x1, y1. So remember, with point slope form, we're going to go y minus this y1 equals slope, which we just found, times the quantity x minus this x1. All right, let me make sure I got that set up right. Y minus y1, so that's great, equals slope, negative 5, times x minus this x1. And then let's just simplify. So we end up getting y plus 1 equals negative 5 times the quantity x plus 2. All right, so last step, we need to find slope-intercept form. We're just going to distribute the negative 5 and then subtract 1. So the first thing I did is I distributed the negative 5, so I get negative 5x minus 10. And then I'm going to subtract 1 over. So that just leaves y here, and then I put the negative 1 at the end. And then finally, we'll just combine these, and that's our answer. So I'm going to write the answer down here, y equals negative 5x minus 11. And there's our equation of the line passing through these points in both point slope form and slope-intercept form. This example says graph the linear function f of x equals 3/5 x plus 1. The nice thing is this is already in our form that's great for graphing. We're going to pick out the m and then b. So slope is 3/5 and the y-intercept is 1. When we're graphing anything in this form, we're going to start with b, begin with b. b is the y-intercept, so that means we're going to go up 1 because the value is positive. And then from here, we're going to go according to the slope. Slope, remember, is rise over run. So from this point, we're going to rise 3 because 3 is positive. We go up 3. So that means we go 1, 2, 3. And then the 5 is positive, so we're going to run to the right. 1, 2, 3, 4, 5. And it puts this point right here. And here's our line. We can put arrows at the end to indicate that the graph keeps going. Couple of things I want to point out. Slope is positive, so as you're going from left to right, you can see the graph is going up. If the slope was negative, as you move from left to right, the graph would be going down. One more thing, your m value, your slope value, if it was negative, you always want to put the negative on top so that you'd go down and then still to the right. You always want to run to the right. All right, next we have 2 definitions. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slope. So again, parallel lines, your slopes will be the same, but if 2 lines are perpendicular, then their slope is going to be opposite reciprocal. So opposite means one positive, one negative. And then reciprocal is like where you take a fraction and you flip it. So let's go ahead and look at the next example. This example says, write an equation of the line passing through the point -2, 5 and parallel to the line whose equation is y equals 3x plus 1. So first I'm going to label this x1, y1, and then we have parallel to this line right here. And so if the line that we're trying to write the equation of is parallel to this, they will have the same slope. The slope is going to be positive 3. So I'm going to take m, x, and y and put it into an mxy chart. So slope is 3, x is -2, and y is 5. So let's go ahead and put these values into our point slope form. So the formula is y minus y1, so we'll use 5. And then that's equal to m, or 3, times x minus -2. And because it says express the equation in point slope form, we're going to leave our answer just like this. This example says write the equation of the line passing through the point -2, -6, and this time perpendicular to the line whose equation is given in this form. And then this time express the equation in slope-intercept form. So first I labeled -2 is our x1 and -6 is our y1. So next I want to take this equation. We have x plus 3y minus 12 equals 0. And we're going to get this in y equals form. Let's subtract x and add 12. So we subtract the x and add the 12, and we just have 3y here, so now we're going to divide out by 3. When we take this term and divide by 3, we can write -1/3 and then leave the x, and then we're also going to divide 12 by 3 and get 4. So now that we have this equation in slope-intercept form, we can see that this is the slope of this equation. So the slope of this line is -1/3. And we want to write an equation of a line that's perpendicular to this one. So from the definition up here, we have perpendicular lines have opposite reciprocal slope. So we're going to take this slope and the opposite, instead of negative, we're going to write positive. Instead of 1/3, we're going to flip it and get 3/1. So positive 3/1 is just 3. And now we're going to take x and y over here, so -2 and -6. And again, I just wanted to emphasize that we took the -1/3 and did opposite reciprocal and got positive 3/1, or just 3. And so now we're going to use m equals 3, x is -2, and y is -6. I'm going to put these values into point slope form. So we go y minus the y1, so we plug in -6, equals slope. And again, we're using this new slope right here. And then we're going to do times x minus the x1, which is this -2. Let's go ahead and simplify this. If the problem asked for point slope form, then we would stop here, but it says express the equation in slope-intercept form. So distribute the 3, you get 3x plus 6, and then we'll subtract 6. So we end up getting y equals just 3x. So here's our equation that's perpendicular to this one and passes through the point -2, -6. All right, guys, thanks for watching Math with Yosh.